Today, we are going to tear down another 6.2 liter GM L87 V8 that has failed. Now, I have done one of these engines just a few weeks ago, but I feel like I shorted you guys with that video because that engine was not recalled. Not only was it not recalled, it was also worked on by people that didn't know what they were doing, which probably led to its early demise. It certainly wasn't a good example to judge General Motors or even any of the 6.2 liter engines by. However, unlike that one, this one is recalled. This is a recalled 6.2 liter L87 V8 out of a 2022 Yukon Denali. I am not supposed to have this, but I do. So the real truth is that I set out lots of feelers trying to find these engines, and I don't like to go back on my word. So the first one I bought, knowing that the second one could also appear, and it did. I bought it legally. It didn't fall out of the back of a truck. It was pulled out of the front of that Denali. I'm sorry. Regardless, this is an engine that we're really interested to see how it failed. We kind of know. GM has updated this recall a few different times since it's been released, and there are different remedies, and it all depends on the situation of the vehicle that is recalled, whether the engine is currently running fine, has issues, or is blown up. Now, the reason I know this is a recalled engine is not just the fact that there are 2021 and 2022 date codes all over the parts of this thing. It's the fact that in the last 10 years or so, GM has decided to stamp the last 8 of the vehicle identification number into the block. So it doesn't matter what late model GM engine I get, unless it's been ground off, I'm going to be able to do some digging. And of course, I'm going to give you guys the details because some of you have connections that I do not. So I can tell you that I did call the dealership with the last 8. I was able to get the rest of the VIN, and then I did a Carfax. Now the Carfax, the details are fuzzier than a Ford 1 liter EcoBoost pickup tube after the oil pump belt has failed, but there are some indicators that vehicle serviced could mean engine was replaced. But I can't exactly tell when this thing was pulled out, but I can tell you that in October of last year, this Yukon Denali had 94,000 miles on it and it was for sale. So someone is still driving this vehicle around. It's still on the road, but I don't know exactly when this was pulled out. So I would say it's out of warranty, so probably after 60,000 miles and then less than 90,000 miles. Somewhere in that arena is when this engine failed, because I can't see a scenario in which this wouldn't be covered unless, of course, it failed in a different way. That's what we're going to find out today. Now, as far as the recall and all of my thoughts on that, I'm not going to waste all of your time and put that in the middle of the video. At the end, I'll talk about how I feel about the remedies and the overall cause of this failure. But for now, let's just get to wrenching. Now, I believe this engine is locked up, and I also believe that it has a non-original oil pan, and that's just because the way the oil pan looks and the way the block looks. It should look pretty similar, but it looks like the oil pan is older or dirtier. So a lot of times when these engines lock up, they have to do things to get the torque converter bolts out, unless they bill out a torque converter, and usually they don't want to do that because they're like $600 to $800. So they usually just dismantle them until they are able to spin. So I really don't know what we're going to find with this thing. The first thing I'd like to do is see if this engine turns over, and if it does, how it feels. Okay, it does. It does rotate, which explains why it had a flex plate with no saw marks on it. So I've seen that before too. I don't hear Uncle Rodney banging around in there. Well, at least it'll be easy to take apart. Next is pull the plugs. So a couple of these plugs got banged up when this engine was being moved around before I got it. But they look like original AC Delcos. I don't know how to exactly tell, but they have a little face on them. There you go. I don't see anything smashed or bent. They all look very similar. They all look like they've got some miles on them. I'd like to make mention that anything I tear off of this engine today, including the block, anything, it's all for sale. It's the business I run. So we're going to pull the intake manifold next. I can tell you it's been off probably to get the harness off, and there's only a few fasteners that are tight. So it's not going to be super exciting. Maybe. And unlike the last one, this is the correct intake. No, we're going to play that game. This one has a complete fuel system. Great googly moogly. That is dirty. It's DI for you. I said DI. I don't see any bits of chunks or chunks of bits. It's just dirty. And that valve is open. These engines definitely could have benefited from a dual injection system, like something that has direct injection and port injection, like Toyota's did in 2007. Just saying. The next thing I'm going to do is start loosening the fuel system. We're going to get the pressure lines cracked loose. Next, we're going to peel off the left-hand valve cover. I'll give it just a little tap. Well, it doesn't look too bad in here. All the rockers seem to be nice and neat. I don't see any piles of forbidden glitter. No silver sparkles. So this has a pretty nice looking golden hue to it. I wouldn't say it's perfect, but it's not super varnished. It doesn't look bad. Pretty happy with the way it looks so far. Now we're going to crack the rocker arms loose. Well, that's not good. So the rockers all look pretty decent. I don't see any signs of oiling failures. They're good. But the push rods, while not bent, there's a bit of varnish. And this one, actually two of these are intake. This is an intake. And this is an intake. So this is the front of the engine. It's exhaust, intake, exhaust, intake. So the first two cylinders on the left-hand bank, the intake push rods, are damaged. What causes that? I think we're going to find out. But yeah, they're not bent. They just have damage. It's strange. Now let's crack the head bolts loose. These are silent. Let's pull this head off. Did I miss something? Oh, make it a little mess, it's fine. Well, the head gasket says front at the front, unlike the last time. And it looks good, unlike the last time. Nice and gaskety. Pistons, not too shabby. Let's do some science. That didn't sound good. So that front one made a different kind of paw noise than the rest of them. Science. Let's take a look at the bores and the pistons. So there's a little bit of wear. Kind of hard to see on camera. Just a little bit. It's not wild. That one looks like there's some more But I don't see any signs that the pistons hit the cylinder head, which is good. I think. It's good, right? The cylinder head looks really good. I'm very happy this one came with the fuel system. Those sell really well. They all look pretty similar. This one's a little wet, but I don't really know how this was stored before I bought it. Now let's get started on the right-hand cylinder head. We start by peeling the valve cover off. Whoa there. We almost had a casualty. This side looks pretty good too. Well, that's not good. They all do that? Maybe it's just because the lifters aren't pumped up. I bet you that's what it is. Or maybe they're all bad. That could be the case too. Boy, I'd hate to see that be the failure here. So everything looks pretty good. Normally when it's chewing on a bearing or something, there's a bunch of metal in the oil, you'll see deposits at the top of the rocker, like right there. A bunch of silvery goodness, or badness. I don't see that here. Not even in the, well, there's some debris down there by the head bolts, but it's not overly silvery. I don't see any sparkles. Now let's crack the rockers loose on this bank. Uh-oh. Uh-huh. Mm-hmm. Ooh. So, the rockers, again, look pretty good. And the push rods, again. Damage. Some of the damage on this is pretty severe. None of them are bent. There's a couple exhaust push rods that are damaged as well. Well, on this one, I got to pull the diff stick tube. What? Now let's crack the head bolts loose on the right-hand cylinder head. Let's go ahead and rip this head off. Well, this head gasket also says front at the front. We're already batting better than the last time. Head gasket. Nice. Aww. Well, that's not good. Maybe it's not so bad. I just fixed it with my finger. That sounds wrong. The rest of this doesn't look too bad, but there's only one way to find out, and that's with some science. That seemed much better than the other side. I mean, kind of better. So the reason for the discontent was the moisture and rust. Now, it's not terrible. I just don't like to see that. It meant that this thing sat outside and got rained on. I don't think that's a coolant stain as such. A lot of times people store these cores outside. But other than that, the rest of this looks pretty decent. Not a ton of wear that I can easily see on the bores. There's some. That piston looks a slight bit cleaner than the other three. I wonder what that's about. And the cylinder head echoes that clean cylinder. You can see these two look different than the rest of them. It's not a huge difference though. I'm not overly concerned.
If you want to see more I Do Car stuff that doesn't usually make it to this channel, some stuff gets posted to my wife's channel. Her channel is kind of the behind the scenes and some of the stuff that she does, so I'm going to leave a link somewhere around here.
The next worst thing I'd like to do is remove the high pressure fuel pump. It looks all right. And now the valley cover to reveal the dynamic fuel management system. So this is the dynamic fuel management system. These are all the solenoids and the harness. And unlike active fuel management that had 4 dedicated cylinders where lifters could fail, this has 8. Whether that means the lifters fail twice as often, I don't know. You GM techs can chime in. But we're going to go ahead and get this off. We got a few 10 millimeters to hold the harness bracket down, and then 1 8 millimeter per solenoid. Well, I just dropped one down in the engine. It's fine. Just don't look at it. The trick is to get them to spin, then they come right out. Most of the time, except for this time. O-rings are a little stuck on this one. There we are. Next, we'll pull the lifters. Well, I've gone ahead and liberated these from their trays. And at a glance, they're all the same height, which means that none of them are collapsed. Or they're all collapsed. I think none of them are collapsed, which is good. That's really good. But then I got to looking with my eyes, and that's not good. Hold on. That's not gooder. Not as good. That's bad. That's got signs that some debris ran through here, but the coup de grace is right here. Look at the roller. Oops. It'll be fine. That is really bad. This has signs of lifter failure. That's not impact marks. That's a roller coming apart. I wonder if that's why this engine was replaced. I have my doubts. For my next trick, I'm going to go ahead and unbolt the water pump once I get an extension.
Battery unhappy.
This is kind of ridiculous. Hang in there, M12. I think somebody had this off and ran it home a little too hard, or put copious amounts of Loctite on it. Now the water pump looks good. It just peed on me. I'll show you. The final thing we have to do is remove the high pressure fuel pump lifter. That looks good. Now we're going to rotate this thing over to pull the oil pan, because that is the next step, as much as I don't like it. I'm not going to put a pan under here. I'm going to live a little dangerously tonight. I believe this engine is drained and has no fluid in it. I lied. Let's catch a little bit of this stuff. Wait a minute. Uh-oh. Oh, I heard my bolt inside. Oh, that wasn't much fluid. Oh, no. It's fine. I got plenty of pig mat here. Wasn't even that bad. Could have been worse. Let's get the pan unbolted. Let's see if I was correct. Yes, this has been off. Oh, that's bad. That is so bad. I did not expect it to be this bad looking, but wow. Barbecued rods, anybody? Holy cow. Okay, so these are all loose-ish. And I think they did that just to get it to turn over. Wow. So this is what happens when you set the timer on your stove for the first time and you set the minutes to hours instead. Holy cow. I am so amazed at how charred these are. So this happens from excessive heat. When bearings spin, when there's lack of lubrication, it creates a lot of heat. And the heat burns, it literally burns the color right out of the rod caps and the crank. And the reason that happens is just like your cast iron skillet or your pots and pans. When you overheat them, they turn a different color. That is the same situation here. Now these look the best out of the pair of the rear two, but if you look, they are still not good. Let's get this crank pulley off. Brought my weighted sockets home. Gotta love it. Let's see if my little guy will do it. I doubt it. Well, color me surprised. I didn't know you had it in you. Why does that fit so loosely? So it fit loose because the snout is tapered. I guess I didn't notice that on the last one. Let's go ahead and get this front cover unbolted. Well, that hasn't been off before, which is nice. We're gonna let that dangle by the harness. It's the right thing to do. And now we'll unbolt the oil pump. Let's get the oil pump stripped. It's very dry in here. I think the word I'm looking for is arid. Let's see if we can just... No, we're just gonna do this. I'm gonna do one of these numbers. Let's take a look. So the outer part of the oil pump has some pretty good grooves in it. Much worse than the last one we tore down. The inner part, some grooves there. But overall, not too bad. But if you look kind of at an angle, you'll see some specks. Can we remove the specks? No. So that's bad. That's foreign material either jammed into the aluminum. And that is aluminum, right? It might be steel. Whatever it is, it's either on top of it or pushed into it. And that means that material has run through the oil pump, which is not surprising considering what we saw when we took the oil pan off. Let's take a look at the actual pump itself. The disc looks good. The flapperoos, technical terminology, I would say average wear. I don't think they're terrible. I bet it would still make oil pressure just fine. Next, we'll remove the variable valve timing cam gear and timing chain. So I went the wrong way and it exploded the timing chain tensioner. That's why you don't go the wrong way. The last one of these I tore down, some jackwagon over-torqued the hell out of them. So hopefully these come out right because they haven't had that guy work on them. Oh, see, would you look at that? That's a little loose if I don't say so. See, that's what's supposed to happen. Let's go ahead and slip this cam out. Well, it's not great. So this part of the cam looks pretty good. It's good until it's not, and that is where it's not right there. Yeah. It's almost like GM has been suffering this problem for a couple years now. I bet this thing was ticking away with my sanity. It's hard to believe such a calamity. I think, okay, well maybe it's just that low. Maybe that's it. And then you get to the rear cam journal. Yikes! We're going to have to look at that cam bearing once this engine is fully apart, because I bet it's imperfect. I have a lot of confidence in the fact that the first 4 rod caps have been loosened, so I'm not going to crack them loose. I'm just going to zip them out so we can push the rods and pistons out. Oh, okay. Can I have the cap, please? Oh boy. So, they're spun. There's where it's not supposed to be. There's where it's not supposed to be. So, the front 2 rod bearings are spun. Not off to a great start. Let's go ahead and push these out. Haha, yep. Okay, it's not welded to the crank at least. Okay, let's turn it over so we can do the next 2. I meant turn the crank over, not the whole engine. Oh, yes, it turns wonderfully. I know I took the plugs out. And I know this might be hard to see, but the nature of the color of the rod journals is sucking the light out of the room. So let's go ahead and get this unzipped. That sounds totally wrong. So here are the next 2. Bad. Can I have the rod, please? It does not want to let go. Well, that one will fall out of the bore. This one is welded to the crank. There we go. Oh, I see why. It's coming with a present. I put my knee there as a stopper. I needed to have that there. Yeah, that's bad. All right, let's see how it turns over now. Oh, it's not any better. It's not better at all. It's the same bad. I'm relatively sure that this pair of rods have not been unbolted, so we're just going to crack these loose. Yeah, these have not been unbolted. Oh, I thought I was just going to pull those off like a good engine. Let's give it a little tap. Ooh, that one was spring loaded. So 3 sets of journals in a row spun. Is that called a hat trick or is it a crap trick? Man. Will the final 2 break the streak? I'm sure it'll turn over nice and easy now. Now, if this were a good engine, this would turn over like butter, but it's still very difficult. It is maybe 10% easier. Okay, maybe like 30% easier. I'm fixing it slowly. Let's go ahead and get the last two at BDC and we'll get those cracked loose. Oh, I thought I could just take those off. Whoa. Wow. Every single rod bearing is spun. Every single rod bearing. I've never seen that on the channel on an 8-cylinder. We've never had a V8 with all the rod bearings destroyed. I noticed in a couple of the previous videos, I've had a few comments of people saying that they've been unsubscribed somehow. I don't know how that works, but I actually noticed it on my own, some other channels I watch. It's interesting. I wonder what's going on with YouTube. Every single one gone. Just gone. Absolutely astounding. All right, let's see how it turns with no rods in it. It should be nice and smooth. It is not. It is smooth but not nice, if that makes any sense. There's definitely going to be more damage that we're going to uncover. That takes way too much force. Let's go ahead and start unbolting the main caps. That was a little work, but someone's been in the front of this thing, whoever condemned it, just to get it. That doesn't want to come out very well. They're in the right order, at least. This will usually get them started here. Wow, it's really tight in there. No, not gonna say it. Wait, it's like it's designed for it. Oh, well, I bet it turns over a lot easier now. All these are loose. The thrust bearing. Those are usually extra fun. I'm gonna have to unbolt two of the engine stand bolts too. Get the rear cover off. I know you guys say that it's a mistake that I make every single time, and I do it on purpose. I do it on purpose because what if I pulled the rear main plate off camera and it had a spun main bearing? That reveal would be terrible. I like the surprises as much as you guys do. Okay, let's get that stand a little loose. Look at all the space we just created. All that's left is to pluck the crank out. I'm gonna have to loosen this up just a little bit more. Oh, the crank is stuck. Okay, this is gonna be a challenge. All right, that bolts all the way out. I'm gonna take one more and make it a little more loose. And it's gonna be fine. You watch. Don't watch. It's totally fine. See, it's fine. You guys didn't believe me. All right, now we're gonna go ahead and pull, or try to remove, the rod bearings and the main bearing, which is delaminating. This is just so much worse than I expected. I expected maybe 2 journals, or maybe 4, but all 8 plus a main, pretty wild. These are coming off okay so far. I'm gonna try to keep these in order. Let's use the old chisel driver here. Ooh, that's pretty solid feeling. Jackpot. I mean, they're playing nice at least. Let's try for this main. Oh yeah. Perfect. I mean, far from perfect. I don't want to. Oh, that one's very welded. The oiling hole is plugged up. That's not right. Oh, really? I broke my chisel driver? It'll still work. I can't believe that did that to me. Using the tool the way that I've always used it. All right. I'm pretty sure we'll be able to get all of them off, which is nice. We get to see what the crank looks like. Let's start with the rod bearings. They're all bad. They're all destroyed. This one is stuck to the connecting rod, and to have such uniform damage throughout the engine is really impressive and not in a really good way. The fact that all of them were evenly destroyed is not an indication that it was run low on oil. It's not an indication that this engine was abused or driven hard. Not saying that people don't drive those vehicles hard and they're not under stress. This is one of those situations where maybe some warning signs were ignored, but the underlying problem is something is defective in this engine. Whether it's the machining of the crankshaft, whether it's an oil pressure related issue, whether it's debris. If it was debris, I would think it would be also all over other parts of this engine. And I don't see how all of that results in all of the rod bearings being this damaged. Now, normally what happens in an engine that is starved of oil or has extended oil change intervals, or it has a manufacturing defect on 1 or 2 journals, it'll spin 1 or 2 rod bearings. And sometimes these bearings will get so worn that they get thin, and it reduces the oil pressure, and then it'll usually roll a couple of these on top of each other, and it'll result in rod knock. The piston will hit the cylinder head, and if they keep driving it, it'll shatter a piston or break a rod. We've seen that 100 times or more on this channel, but that is not the case here. The pistons look great. Nothing struck the cylinder head. They all rolled in their journal. That's not what they're supposed to do. Now, the rods, these 2 were probably the least affected. None of these are going to be good. 0 of these should be reinstalled. However, if you would like to own the rod and piston with matching bearing out of a recalled engine, and this is probably the last time I'll get a chance to do this, I'll sell all of these, because that's the business I'm in, selling parts. Whether they're for reuse or a desk ornament, let me know if you'd like one of these. Now, the pistons have pretty average wear. They're not bad. The rings aren't chock full of oil deposits like a lot of late model engines. These look pretty good. Some carbon deposits on the top. Nothing notable here. That one's got a little bit of a deep groove in it. Now, one of those cylinders did have some moisture sitting in it for a while, which left some rust, which could have been this one here. We did turn this engine over, and I don't know, sometimes, you know, these things sit on a parking lot for 7 months waiting on an engine, so you don't really know how this situation worked with this truck, because I wasn't there when it was fixed, and I wasn't the one to work on it. I just bought the core engine. And then we get to the main bearings. They're not good, especially this pair of shells right here. I am very lucky that these two did not spin. They were very close from spinning. You can see that this one has some bearing foil starting to flake off of it. It was moments away from that. I think it eventually had so much resistance to turning over that the engine locked up, and that's what kept those from spinning. But none of these are good. These are the nicest pair right here, and I would still consider that pretty heavy wear for the miles and the age of this engine. It's not good. Now let's get to the crankshaft. The first main journal, pretty heavy damage. Every rod journal damage. This was the main journal from that main bearing that was coming apart. I mean, every single one of these. And I'm kind of bummed out here because I was really hoping that I'd have a good pair of journals to cross-section a crank and ship it over to Lake Speed, because we talked about it, and if I had one that was undamaged, which is not the case here, I was going to send it to him so he could use his surface analyzer on it, which I don't have one of those fancy things. But in this case, I don't have one to send him. I mean, I could send him a main, and those look okay, but I still think it's not a good representation because this engine is post-failure. Now, there's some other things here that I'd like to point out that I did not notice at the very beginning. It's kind of interesting. And here is where it gets interesting. Look at the damage to the block from making contact with the crankshaft. This happens only two ways. This only happens from two different reasons. Number one is that a piece of debris can fall in here. However, usually that's one deep groove, or two maybe. And there's nothing wide enough that would cause this kind of damage. Now, the other more probable reason here is that this crankshaft had excessive end-to-end play, which is basically the clearances, the tolerances for the crankshaft to move back and forth. If it moves too far this way, it can make contact with the block, which is what has happened here. And now what's in charge of keeping the crank from moving that way are the thrust bearings, which we will look at in just a moment. But when crankshafts do have excessive end-to-end play, it can put the connecting rods at an angle because they're not designed to go that direction, and that can cause rod bearing damage as well. And there's clear signs that this has made contact with the block. There's some aluminum transfer on the front of it. It's not from a piece of debris. There's the thrust bearing contact on the crankshaft, and there's some damage there. So here are the thrust bearings out of this engine. Now these, the Gen 5 engines and later, are only 180 degrees of thrust bearing, whereas the Gen 4 and down, Gen 3 and Gen 4 engines, the superior engines, fight me, those have 360 degrees of thrust bearings. These are only on the engine block and not on the main caps on a Gen 5 and later. But I don't think that's the problem here because the 5.3, the L83 and L84 are this way, and these don't have those issues. However, these look kind of worn to me, and I did try to find the specs for the thickness of these thrust bearings, but I couldn't really find that. I could find the end-to-end play, the crankshaft runout, which you would just put a dial indicator on it and push the crank forward and back when it was installed in the block. But I couldn't have measured that with this engine because this engine was so far gone and it was almost locked up. Someone had to unbolt some of the rod caps to get the crankshaft to move, that I couldn't get an accurate reading. So it was impossible without tearing it down to see this kind of damage. This may not be the most accurate tool, but it is made in a fine town in Pennsylvania. But there's the thickness. So anybody that has some thrust bearings laying around from one of these engines, let me know if these are worn. Put it in the comments what these are supposed to be spec'd at. As promised, I wanted to look at the rear cam bearing because we saw some damage to the camshaft, and there's definitely some damage there. Still looks better than every 5.3 or 6.0 Gen 3 or Gen 4 engine I've ever seen. Maybe. If there is a bright side here is that I think I have a sellable block. The bores look pretty good. With some vertical scratches, but I think they would clean up. This is the cylinder that had the rust stains. You can only see them, you can't really feel them, so that's good. The other bank, not too bad. There's some stuff in there, it's fine, don't look at it. This one has a pretty deep gouge in it. That's probably going to require some machine work, but I don't think it's outside of what the specs are, or tolerant specs are for this engine. Collectively, these three trucks, SUV, have over 650,000 miles. That's on the original drivetrain. This is on the original drivetrain. This has had an engine, a used engine put in it at some point. They all are well over 200,000 miles. And I don't know that we're going to see that with the trucks they're making today. And the trucks they're making today are more expensive. They cost a lot more. So you're getting less life out of them and you're paying more. It's not really a good combination. And that's why a lot of people are hanging on to their older vehicles, because they don't have these problems. Sure, they do have problems, and you have to contend with age and things breaking when they're 15, 20, and 25 years old, but they're usually solvable things or preventable. This is not a preventable failure, unless you're, of course, GM. Lake Speed recently put out a great video talking about the oil specification differences on the 6.2 liter GM V8 engines. The cars, the Corvettes and Camaros, which have the same basic engine as the L87, same rings, same pistons, same rods, same bearings, same crank, same block. It's the same basic engine. Outsides are dressed a little different. Those are specified to run 0W40, and we're not seeing the failures we're seeing in the trucks and SUVs in the Corvettes and Camaros. Now, they did sell a lot fewer of them. That's part of the reason. The L87 powered vehicles, those are specified to run 0W20. Now, why would they do that? So 0W20 has a lot less margin of error for tolerances, differences in tolerances, machining differences, and also contaminated oil. It's a lot less protection, but if all of your machining is excellent, I think it would do just fine. But in this case, it wasn't excellent. Now, the reason they spec'd 020 is not because it's better for the engine. It's not because it's better for you, the owner. It's not significantly cheaper oil. It's because it allows the engine to get slightly better fuel economy. Just a little. We're not talking about 5 or 10 miles to the gallon. We're talking about maybe 1 or 2. It's not a huge difference, but for every unit GM sells that doesn't meet CAFE standards, they have to pay a penalty by how far it doesn't meet those standards. So 1 mile per gallon may be a huge difference, because that's a penalty on every single vehicle. They sold a ton more trucks and SUVs, so they specified a lower weight oil for those vehicles. And now they're paying the price because their machining and tolerances weren't correct. Something is wrong with the crankshaft itself, or something around the crankshaft. Now, I will say this, the 5.3 liter L83 and L84, specifically the L84, we're not seeing the same issues. They are basically the same design, just a smaller displacement. So clearly the difference is somewhere in the components and not the design of the engine, because those engines seem to be as reliable as their predecessor. That's the best way I can put that. But GM did this to save money, and it's costing them more, because the penalty they would have paid per vehicle sold if they had specified 0W40 in these vehicles was going to be way less than putting an engine in a vehicle, and also the harm it does to their image, this huge recall, the fines, all of this stuff. And that leaves the door open for how much else? What happens to the person that owns this Denali, or owned this Denali, and then sold it at a loss, or had to put a used engine in it? And is the used engine covered? Now, obviously, they can figure out if the used engine installed was one that was recalled or not, but there's a whole bunch of gray area. Also, as a salvage business, if I were to buy a 21 to 24 Escalade or Denali, or one of these vehicles with a 6.2, can I sell the used engine? I mean, it's the vehicle that's recalled. It's not the engine itself, but I wouldn't. There's no way I would. Absolutely not. Now, if I owned one of these vehicles and I was concerned about it, I would just run 040 in it. The penalty on fuel economy is nothing compared to being on the side of the road in the middle of nowhere waiting on a tow, or being without your vehicle for months waiting on a replacement engine. I'm sure GM is filled with financial regret at this point because they put all of their chips in the basket, eggs in the basket for the CAFE standard penalty and not in the engine longevity. But if the tolerances and machining were correct, maybe it wouldn't have been as big of an issue. They basically operated with such a thin margin of error, and there was error here. Now, my understanding, and this is after talking with Lake Speed some, is that the crankshafts were shipped to the Towanda engine building plant in a, I wouldn't call it a raw condition, but an unfinished condition. They needed a final polish before these engines were assembled. And they have some machines that probably polish each individual journal, or maybe all of them at one time. And it could have been that the surface finish on a couple of the journals was rougher than specified, and the machine only works for X amount of time. Maybe it's 15 seconds, maybe it's 2 minutes. I don't know. It's just an arbitrary number. But it may have needed more machining time, but the machines were set up for a certain tolerances for surface finish. It could have been a calibration issue with the machine. It could have been a problem with the machine. It could have been that the sanding material with the emery cloth, whatever it was using, should have been changed out more often. I don't know if we'll ever find out that, but there was a problem. But none of that fails in comparison to how badly GM has handled this huge debacle. I think this is they screwed the pooch here, because these engines have been failing since essentially like day 3. So I've seen these engines bad with 750 miles on them, locked up solid. This has been a problem for years. The earliest recalled engines are 2021 model year, which means in 2020 these engines were failing, and it's 2025. GM could have said, okay, we have a problem with these engines. There was certainly enough data for that. Let's specify 040 until we can figure this out. That would have made many more of these engines still left on the road today, and it would have at least smoothed out the huge hump of failed engines to replace. It would have kept their cores in better shape. They might have still had to replace all of these engines, but it wouldn't have been so much in a short period of time. And the fact that they didn't acknowledge this failure to the public, they acted as if nothing was wrong. It's a pretty bad attitude towards the public. GM used to sell cars for everyday people that could be serviced by everyday people, and I know pretty much nothing made today is service friendly or user friendly, but the attitude towards the repairs and fixing these vehicles has gone downhill much further than I anticipated. GM doesn't like seeing used parts put on these vehicles, even if they're 10 or 15 years old. I could go into the global module thing. I'm not going to. I'm just not happy with the way GM handled this, and I don't think anyone else is either. Several of you people own these vehicles. It's a very common vehicle, and I think you're going to have to wait a long time for engine replacement. Over the last 4 years that these engines have been around, or 5 years, I've seen stories of people waiting 6 to 8 months, maybe 10 months, which would explain why putting a used engine in one of these vehicles may seem like a good solution. So this was a teardown that may not exist again. GM is very particular with how they get their cores back. If you buy an engine at the dealership, oftentimes the core charge is more expensive than the actual engine itself. They want their cores back, which is why I may not get a chance to get another one, not a recalled engine. So I hope you enjoyed this teardown. If you'd like to buy any of the parts out of this recalled engine or anything else I've torn down, or if you want to peruse our inventory, I've been uploading our parts cards every single week. You can go to importapart.com. If you don't see what you like on the website, shoot us an email. A lot of times the parts from the teardowns don't make it onto the website for quite some time, so email is the best course. As always, I love all the comments, all the feedback, and even the criticism. I love it all, and I'll catch you on the next one.